And now we'll take a moment to look at the future of human spaceflight with that simulation of an asteroid mission. We'll go to the facility at the Johnson Space Center where that's taking place with Public Affairs Officer Brandy Dean.
Good morning. Welcome to the Space Vehicle Mock-Up Facility, or Building 9 as it's known here at Johnson Space Center. We've got some interesting activities going on here today. A simulation of a mission to an asteroid. If you are a regular watching the ISS update, you know that a lot of what we do is to get ready for future exploration. And this is another activity that goes on here at Johnson Space Center to help us get ready. And to tell us about it today, we've got astronaut Mike Gernhardt here. Thanks for coming, Mike.
Great. Well, it's nice to be here. And what we're doing here today is very interesting. It's what we call a 3-day integrated asteroid simulation. And we're doing it with the Space Exploration Vehicle, which some of you know started life as a lunar rover, and then it's morphed into an in-space vehicle where we replaced the chassis with the wheels with our reaction control jet system. And so we've worked with the engineering team here at NASA, and we've developed this really great integrated sim where we're actually living in the Generation 2A Space Exploration Vehicle. And we have an asteroid sim, and we have that projected on a big screen in front of the cabin. So we're actually flying around the asteroid. We've defined some standard protocols where we do what we call the near field survey, which is we fly all the way around it at 30 to 50 meters off the surface. And then we have this 100-foot diameter area of geological interest, and we've simulated sampling with 6 cones. So we actually have to fly the vehicle and the arm on the end of it up and touch the 6 cones. And we're measuring handling qualities of the vehicle. We're looking at prop usage. We're looking at the viewing out the windows, the kinds of rendezvous tools we need.
And so they're actually living in the cabin.
They are living in the cabin for 3 days because we've just finished building the cabin 2A. We want to shake it out, what's good about it, what's bad about it, you know, what it's like to live and work in the cabin. And
so now you've lived in the cabin before, not this particular cabin, right? This is a new version of it.
Well, I've lived in the 1A and the 1B up to 2 weeks, and in December I lived in this cabin for 3 days doing a similar sim to what we're doing today.
Okay. Well, how is it? What does it feel like?
It is really cool. The asteroid sim is very high fidelity, and we've integrated the SAFER jet packs from their virtual reality lab.
You might explain what SAFER is.
So SAFER is a jet pack that we use on space station if we should fall off and break our tether. It's a way to fly back with cold gas propellant. And we have a virtual reality lab where we can actually fly these SAFERs around in that environment. And we've managed to co-sync the SAFER sim with the MMSEV sim. So we have one crew member on a jetpack flying around while the vehicle is monitoring him and maybe coming in and rendezvousing with him while he gets in the arm to do samples. So we're really getting a very high fidelity dynamics understanding of what it's like to work on an asteroid. And then we're able to start spinning the asteroid at different rates and see what that does to your workload.
Because we don't know what asteroid we're going to yet?
We don't know exactly what asteroid we're going to yet, and we're trying to develop a set of tools that will allow us to optimize the hardware depending on the characteristics of the asteroid.
Okay, well, we're going to be talking with some more people later in the hour, and we'll be over by the cabin that the crew is living in. But can you tell us a little bit about what we've got behind us here right now?
Yeah, so the other thing that we're doing is every time we get out of the vehicle, we are getting into a suit through the suit ports.
A space suit?
A space suit. This is our Generation 2 suit port, and we're trying to evaluate the mechanics and the human factors of those suit ports. So we typically will do 3 short EVAs a day, so we're getting out of the vehicle 3 times a day. Some of the times we go up to the SAFER VR lab, and the rest of the time we come over to this Argos facility, which is it's basically a gravity offload system. It's an electromechanical control system. You get in the harness. We've got a number of different sampling tasks with rocks here. We're evaluating different translation lines, lightweight booms that we anchor and then move the other end, kind of inchworm around and so forth. And so we have a standard protocol that we're doing here that we actually did at Nemo 15. So we collected data from under the water in that environment, which might be somewhat biased by the drag and viscosity of the water. And so we're repeating those same tests here with Argos. So they will do a 6 sample collection task here and deploy a seismic instrument. And
so it looks like they're getting set up to do the next run now. Maybe if we draw it out a little bit, we'll get to see a little bit of it.
Maybe you'll get to see some of the suit up.
Yeah, but so this is one of a suite of different ways that NASA looks at how we would explore an asteroid, right?
Exactly, and we're looking at all aspects of that, from the robotic precursor to the infrastructure that we need. And right now our basic plans are to have a deep space habitat that we actually travel to the asteroid in, and then once we get there, we would transfer into the smaller space exploration vehicle and then excurse over to the asteroid and stay there for a week. And the reason we do that is that it actually takes a lot of prop to get from the deep space hab to the asteroid if you want to go there fast, and then if you come back, you have to take all of that energy out. So it's much more sensible to go over there and stay there for a week. And so what we're doing in this simulation is trying to create a high fidelity sim of what the operation really looks like. That helps us do the habitability analysis of the cabin, because if you were just sitting in the cabin, playing Parcheesi all day, that's not flight-like. And so, we have a very tight timeline from morning till night where we're flying the near-field survey, we do the Argos, we do the SAFER, we've got a bunch of other stuff we're doing inside the vehicle. So from a crew member, it feels a lot like an asteroid mission. And then on top of that, we're simulating the time delay associated with the 50-second each way that it would take to talk to the ground, and
it would take their voice, if we send something up, that long to get to the crew in space, because it's so far away.
It would take that long to get to the crew in space, and so we really need to understand what that means to how we manage our operations, how we manage our systems, and so forth. And so what our whole team is trying to do is understand that whole mission at a nuts and bolts level, not at an architecture level, but at the nuts and bolts of how you would really execute it. And from that knowledge, we can then design the right hardware from the beginning, instead of having, develop this hardware and then you start doing some ops with it and you say, I don't like this, I don't like that.
You don't want to get to the asteroid and figure out you don't have the right tools.
Exactly.
Okay.
So we're working, years ahead of that to understand those things.
Well, along that line, I guess this is Jose Hurtado, who's getting set up, a geologist with University of El Paso, right?
Exactly, yeah.
So why haven't geologists involved?
That's a good question. I actually lived in the rover with Jose a couple summers ago, and we're trying to really understand, and we do this at Desert Rats, but we do real geology, and we actually have metrics where the professional geologists score how productive we are and the conclusions we reach, so we can evaluate different combinations of cameras and tools and so forth. And so I think it's very important to engage the scientific community in this evolving process, so that we can really do the best science we can when we get there.
Okay. And the other half of the crew this time is astronaut Alvin Drew.
Exactly.
So you also want the astronaut perspective,
Absolutely.
I'm sure.
And so that's what we've done traditionally in Desert Rats, is team an astronaut up with a professional geologist, and that kind of helps us learn geology, which, that's kind of where the astronaut office is going, is to become, an observational scientist as well as an astronaut, because any one of these exploration missions, whether it be the Moon, Mars, NEOs, and so forth, we're going to need to become good observational scientists. And the scientists say that we're actually the best scientific instrument they have, and so we're trying to get that cultural change from, test pilots and arm operators and very procedure-oriented folks to the more the operational, observational science.
All right. Well, lots of cool stuff going on there.
You bet.
Okay.
You bet.
Thanks so much for talking with us.
Okay. Nice to see you.
Okay. And this is all part of the RATS, or Research and Technology Studies, series of tests that we do. So if you want to go and find out more online, you can visit nasa.gov/desertrats. Again, that's nasa.gov/desertrats. And we'll go back to Kylie for now, but be back to talk to a few more members of the team later. Thanks so much.